Here we will try to show how to find the square root of a line segment. Actually, we cannot find the square root of a line segment normally, but we can mock it with the two similar triangles. Here we can see the two shaded area are there. One kind of shade is here, which is one kind of triangle, and this another shade is there, which is showing us a different line segment, different triangle, but those two are similar. We can show the picture more clearly if we delete the polygons, that is the shaded area. Here we can see the if we remove these polygons from here, then we can see the nature of the conditions of these similar triangles. Let's see how can we show it better. Here the simple theory is this L is the given line segment, that is the green color line. If it is 1, then 1 into tan theta is this one, this line, which is the triple arrowed, which is this one is the 1 into tan theta. And if this is the base again, then this red colored line is the 1 into tan theta, that is the tan square theta. So x is, this red colored line is the square of this perpendicular line, this one, which means if we know this x, then we can find the square root, which is this green color, this perpendicular line, which is taken from this circle. How can we construct this? For is shown here. Now we will explain it simply with the, suppose here we are deleting it, this polygon, then this part is cleared. Now there is another polygon. If we delete this, then we will get the clear area here. Now this is a circle which is drawn to get the projection point. I am explaining you here how can we find the square root of x. This x, this red colored line, this is a small line segment, and we are trying to find the length of this line, which is the square root of x. How? Because these are the two similar triangles, we are drawing it. How? We are explaining it here. Suppose this line segment is given, the red colored line segment is given. We are trying to extend this line and drawing a unit length, unit distance. Here we have taken a 1L to expand it, to show it such that it can become visible. We are not supposed to draw it of any kind, any length. We should draw it as the unit length, that is 1. We should take its length as the 1, then only it is valid. This angle is equal to this angle as per the construction, and these two similar triangles are formed such that we can explain our whole mechanism here. And from the theorems that we are seeing in our class 10th geometry or in our school level geometry, Euclidean geometry, we know that the art of drawing two similar triangles through the circles, and if we draw any triangle on the diameter, then this two line will always make 90 degree. Two chords will always make the 90 degree, we know it, which are subtending the angles at the end of the diameter. That is a theorem. As per that theorem we can get this. Now if we don't hatch this circle, if we don't hatch this one, suppose if we don't hatch it, if we set it as a hatch as a none, hatch as a standard, or hatch as the dots, and then there is no hatching. Now we are getting it more clear. If we draw a, suppose if we draw the radius from the center of this, then we can make it more clear here. Suppose this length is given. Now from this length we are extended it with the unit length. Here 17.31 or other thing is wrong. We should take it as a unit length, and if we take it as the unit length, then if this line is of unit length, then this total length is the x plus 1, and taking the midpoint is the x plus 1 divided by 2. This is the midpoint. How can we draw it? By using the midpoint, or as per the school geometry construction rules, we can get that. Now from this midpoint, taking this center and taking this point as the end point, now we can draw a circle. We can draw this circle with the center and radius, or the center or through point, and then we have drawn this circle, and from that circle we can project it as the perpendicular to this line, and where it cuts, when we get the intersection from this formula, that is getting the intersection point through this toolbar, or through as per the school geometry construction rules, we can get that. And from there we are drawing these two lines. These two lines are drawn, and after these two lines are drawn, we can see that two similar triangles are forming, and when we measure these angles, we can say that these two angles are equal. Suppose if we are changing these, or if we are changing these positions, or if we are changing this position, this is a self-locked position, this is constructed through this. If we change these positions, and if its length is 1 unit, then the blue line will automatically come as the square root of x, because this red is the tan square theta 1. If this is taken as a 1, then 1 into tan theta is this one, and if this turns into the base, then 1 and the theta are same, this one and this angle are same as per construction. So if we take it as the base, then it is another again the perpendicular, so it is tan square theta. Obviously this is 1 into tan theta, and this one is the 1 into tan theta, and this one is the 1 into tan theta into tan theta, so that is a tan square theta. Obviously this red line is the square of this blue line. Understood? And this is the concept in which we can construct the square of a line, or a square root of a line. If this is given, and if we have to find the square root, then we can generate the whole thing with the additional construction with the 1 unit length. Here this length is bigger than 1, so it can give the wrong values. If it is 1, then it will give the right values, then it will give the proper values for the square root. I think you could understand the concept.